Hi everyone, this is practice summative of chapter 4, question number 2 in paper 1. So for part A, we have to show that NCR equals to NC n minus R, whereby n and R are positive integer. N is greater than R. So how do we do this part? Let's start with the left-hand side, NCR. So what is the formula when we see NCR? That is n factorial over R factorial and then n minus R factorial. So isn't it we can flip this commutative law? A times B equivalent to B times A. So we have n factorial over n minus R factorial and then R factorial. And the R factorial basically can be written as n minus R factorial, isn't it? Okay, isn't it? This will be n minus R. So we have just shown that NCR equivalent to NC n minus R. That's it for part A. Next, part B. So for part B, we have to find the value of R if NP R divided by NCR equals to 120. So in this case, let's write the formula for NPR and NCR. Okay, the formula for NPR is n factorial over n minus R factorial. And then divided by, for NCR will be n factorial over R factorial n minus R factorial equivalent to 180. So we will have n factorial over n minus R factorial. Change the divide sign into multiply, and therefore the fraction that follows we need to write in its reciprocal. Okay, so all this equivalent to 120. And we can simplify n factorial with n factorial, n minus R factorial, n minus R factorial. We're left with R factorial equals to 120. So R factorial, let's use R factorial. We know that we need to multiply the series of numbers when we count down from R. We can also count upwards. In this case, 1 times 2 times 3 times 4. We continue to multiply until we get 120. That is the only way, try and error. Okay, but we try by count. Instead of count down, we count up and we stop the moment we get 120. So 2 times 3 is 6. 6 times 4 is 24. And then when we times 5, we get 120. Therefore, R is 5 because 5 factorial is 120. That's it. So we found the value of R.